differential equation is x into dy by dx is equals to y plus x into e power y by x. Now he's asking by which substitution this given differential equation can be converted into variable separables. Now the given differential equation can be written as dy by dx is equals to y by x plus e power y by x by y by x. I mean x by x, which is nothing but dy by dx is equals to y by x plus e power y by x. Now clearly this expression is nothing but homogeneous, so it is nothing but a homogeneous differential equation. So in order to convert this homogeneous differential equation into variable separable, the substitution is v is equals to yx, so the option is C. We have to find the Laplace transform of the function e power minus t into sine 2t. Now we know that Laplace transform of e power minus at into sine omega t is nothing but omega by s plus a whole square plus omega square. Laplace transform of e power minus t into sine 2t. Now clearly the value of a is 1 and the value of omega is 2. Just substitute 2 by s plus 1 whole square plus 2 square, which is nothing but 2 by s square plus 2s plus 5. Option A is the correct answer. In the direction in which the function x square plus xy plus y square increases most rapidly at a point minus 1 comma 1. So in order to find the function, we have to find the value of delta f at minus 1 comma 1. So delta f is nothing but 2xy into I plus x plus 2y. You will obtain this after differentiating and simplification. So delta f at minus 1 comma 1 will be nothing but minus I plus j if I substitute x as minus 1 and y as 1. So the answer is option B. It is given that A is a square matrix and is asking when does A satisfies the condition adjoint of adjoint A is equals to A. Now we know that adjoint of adjoint A is nothing but det A power n minus 2 into A. So this det A power n minus 2 into A will be equal to A if mod A is equals to 1 or the order is 2. So the answer is option D. To find the value of the limit sin x by x if x is tending to infinity. Now as x is tending to infinity, we know that 1 by x tends to 0. Hence sin x by x also tends to 0. That is option C.
Question is, if the ratio of longitudinal shear stress induced in the two beams of rectangular and circular cross sections of same areas for a given constant vertical shear load will be. So the longitudinal shear stress, we have to find out the ratio for rectangular and circular, that is equal to tau r by tau r by 2, that is equal to 2 times. So option C is correct. Two bars of material A and the other of material B of the same length are tightly secured between two unyielding welds. Coefficient of thermal expansion of bar A is more than that of bar B. When temperature rises, the stresses induced are usually, it depends on coefficient of thermal expansion when one bar is attached below the other, but here the two bars are attached by a weld. So the coefficient of thermal expansion is not going to be matter over here in this particular question because of it is welded. So the two bars, when the temperature rises, two bars are going to subjected to compression. So both A and B are going to subjected to compression. So option D is correct. The question is, which of the following statements is true for the figure shown below? So the figure is shown as the load of 3 tons is acting at C. So we have the options here, the moment at A, moment at B, moment at C, MC represents. So the moment at A is greater than MB is suits for the figure shown above. So option B is correct. Question is, the maximum bending moment due to train of wheel loads on a simply supported girder. So if you take a girder, it is simply supported, a train is moving, wheels are moving. So where the maximum bending moment is going to occur, the maximum bending moment diagram is going to be something like this. So maximum bending moment is going to occur, always occur under the wheel loads. Wherever the wheel is going to be there, under this the maximum bending moment is going to be there. So option A is correct. The question is the design bending moment of a beam shown in the figure. Here a point load of 4 kN and a moment of 4 kN meter and 2 kN meter is there. So design bending moment is the equal to 4 into 4 kilonewton meter is already there, minus 4 into zero point 0.5, 4 into zero point 0.5 is equal to 4 minus 2, that is equal to 2 kilonewton meter. So option D is correct. The velocity distribution in a turbulent flow is a function of the distance measured from the boundary surface and friction velocity u. It follows a logarithmic law. It is a direct question. C is correct. A calcium chloride as an accelerating admixture is not recommended for the use with calcium chloride. We use it to add up the to the cement the rapid hardening. So if you use a calcium chloride in a particular cement, it is going to increase the speed of setting. So we can use it in any type of cement, whether it is ordinary Portland cement, high aluminum cement, or rapid hardening cement. It is usually contain on its own the calcium chloride. So none of these is the correct answer. The question is not recommended for use with. We can use it with all these three types of cements. So none of this is the answer for the above question. Question is the rise of water table below the foundation influences the bearing capacity of the foundation soil by decreasing the. What is going to be the effect of water table? The question meaning is on the foundation soil. So we know the bearing capacity equation is a factor of depth of foundation, unit weight of soil, cohesion. CNC plus QNQ plus half gamma B n gamma. Terzaghi bearing capacity factors NC and Q n gamma, and C is cohesion. Q is gamma into depth of foundation. Gamma is unit weight of the soil. B is width of the foundation. This is Q, ultimate bearing capacity or bearing capacity of a foundation. So effect of unit weight. The water table is going to rise. The unit weight is going to decrease. Gamma minus gamma W, gamma saturated becomes. So the effect on the unit weight is going to be there, and it is going to be on the cohesion. Effect of water table on the foundation is because of cohesion and effective unit weight. So option B is correct. The question is the porosity of a soil sample N is given as 30%, that is equal to zero point 0.3. The void ratio E we have to find out. We know the relationship between void ratio and porosity. N is equal to E by 1 plus E. By substituting zero point 0.3 is equal to E by 1 plus E, that implies E is equal to 0.42. So option B is correct.